So we got a couple of things left to do on this. We still have to finish the electrode holder or the rod holder. So on the inside, we're going to almost replicate what we have going on here. We're going to put another piece of sheet metal in there with the same diameter holes that are sitting a little bit lower. That way the rods are kind of angled down. What that's going to do is going to provide a little bit more rigidity into the frame, make it a little bit more solid. We're also going to add a foot pedal holder and the electrode and hose holder, as well as build a bottle rack for it. All right, so our first step is going to be taking this kind of template here, or this hole pattern, back over the Quickie table and redrawing the internal part of this to receive the back end of the rod holders. We won't need the logo since it's going to be on the inside. Dropping it down is going to give us a little bit of an angle on there, so when the operator's, if he's working at a table with a chair, he'll be able to grab these. You don't have to worry about the filler metal falling out. So we're going to go ahead and get that drawn up on the Quickie table. So let's go. All right, guys, so what we've done is we've just made the cut profile for the back side of the electrode holder, or the rod holder. So I elongated the holes, that way when we put the rods in at that change of angle, it's going to be able to receive those. So I made these holes 2 1/4, whereas the OD on the front part is 2 inches. So that's going to be able to account for that angle. So it's going to sit a little bit lower. We want to try and set it below the logo of the Heffner Performance, and also ease of accessibility for the end user. So I've elongated the holes, and then I took the plate dimensions, so we're just taking a square plate and I've shrunk it on here to the internal size of the welding cart. So what that's going to do is it's going to allow us to weld everything up on the inside, but it's going to act as a stiffening bracket as well. So it's going to hold the rods and it's going to support the cart. It's going to make it a lot more rigid because, like I said, we're using 1/8 inch material. So we're going to go ahead and get ready to cut this out. All right, so basically what we're going to do is I'm just going to get some dimensions on the foot pedal. Doesn't have to be to scale on the cardboard, because once I transfer it over to the CAD system, everything will be to scale. So I just want to draw a rough outline, figure out exactly where all my brakes are going to go, figure out how long I want the pieces to be and all that. So we're just going to go ahead, and so I've got 5.5 here. So I got to make sure that the internal, once I put the bends in there, is at least 5.5 inches. So I'm going to start there. Okay, and then I know I'm going to have a drop this way, and I have to figure out, so I need at least 8.5 inches here, but then I've got to compensate for this cable. So I'm going to run that at about 4.5 inches. And now this side I can leave this up much longer. Most of the foot pedal pieces have a much longer piece on this side than here, because over on this side I have to compensate for that cord. These are where my bends are going to be here, so I want to make sure that I have, just use a dotted line, tell me where I'm going to fold, and then I'll just put relief cuts in. Just gives me reference so that I know when I go over to the plasma cutter to draw this out, I get all my relief cuts where I need them. Now I know I measured just a handful of cable earlier, and I know I want this area right here to be at least 5.5 inches. And then I'm going to have a 1 inch lip right here. And then this area right here, we're going to have, I'm going to dot that out for a bend. So we'll go ahead, we'll take this over to the CAD system, input it, make it actually to scale, and then we'll go ahead and get that profile cut out and then cleaned up, bent, and we'll go ahead and attach it to the cart here. right, so what we did is we took the print that we just drew up over there on the cardboard, we transferred it over here to the CAD system. A lot easier to draw on the cardboard, you got a little more free room to play. So we transferred all that over here we based everything off the Nova foot pedal, so once we fold this thing up, it should fit in there nice and neat. I went ahead and actually extended this a little bit more because I think with most the holders for the foot pedals, they don't give you ample room to store your cable and stuff like that. So we went ahead and extended that, as well as the lip that's going to retain that. We have the relief cuts in there. That way it's going to be easier to fold, kind of like we just did with the cart. So we're going to go ahead and transfer this to the CAM software and then into CNC, and we're going to go ahead and cut that out right now. All right, so we just finished our cutout. We're going to go ahead and grab the piece, take it over back to the tab and slot table, hit it with the wire wheel, get that remaining dross off, check the dimensions again, and then start our bends. One thing I want to do typically when I do my bends and layouts and stuff, I mean, you definitely want to label which way is the front and which way is the back. Because I have that cable coming off the foot pedal, if I bend this backwards, the pedal's not going to fit in there at all. And it's just going to, you could probably slam it in there, but it's just going to tear up that cable over time. So I want to make sure I get all my bends right. So these, I'm just going to face this and say I'm bringing these up. And this is as the front view is. All these are going to pull up, so you know, this way if I set the piece down or move it before I get to bending it, I've got a visual representation of where everything needs to be before I start bending it. As it's laying on the table, I can double check, I can look at it and say, okay, this is the way it needs to go, because I should have the back side up as I lay this on the edge of the table and break them. I'm going to go ahead and try to bend some of this. I may need to put some relief cuts in here, I don't know. But we should be good. So we're going to go ahead and start bending. It's all about manipulating that metal. So far, turning out pretty decent. We're gonna test it out. All right, foot pedal holder's done. We're gonna go ahead and mount that at some point, probably right around in this area here. But up next we got to do some torch holders and a work clamp hold. So we're gonna go ahead and bust out the old cardboard aided design again. All right, so we're gonna start off with something simple, really simple. I'm thinking just like a rectangle with a couple tabs on it that we can go ahead and bend the tabs up. That's gonna retain the cables from falling off. I want to change up the design a little bit, so I'm probably gonna wrap it around like a 6-inch piece of pipe, because we're gonna get a little bit of spring back when we bend it. So that should give me about an 8-inch round piece to work with. So we're just gonna do something really, really simple. So I'm thinking a piece about 12 inches wide, or I'm sorry, 12 inches long, about 3 inches wide. And I'm probably just gonna come off with a couple tabs, about 2 inches long, 1.5 inches wide, you know, just kind of space them out kind of equal. And I'm gonna go ahead and do probably fillet these corners here. It's like putting a radius in the corners, make it nice and easy. Don't want any sharp edges for anybody to snag any clothes on or body appendages or any of that stuff. We're gonna build 2 of these, one for the TIG torch setup and then one for the workpiece clamp. So without any further ado, we'll get over to the table, we'll design it out in the real CAD system, and then we'll start cutting. good's a welding cart without a bottle rack. So we're gonna go ahead and sketch something out here. Mancub and I talked about a couple different designs. We both agreed that we'd rather have one that we could roll the bottle up into versus picking it up, manhandling it. All right guys, so basically, you know, pretty much the same design as we had over there on the table there with the cardboard. This is it. I think this is gonna work pretty decent. The bottle's gonna sit right in this area here. This is the tab on the bottom that's gonna fold down towards the pavement. These are gonna fold up on the sides. These are our two tabs that are gonna fold in to kind of secure that bottle in place. This one in the back is gonna fold up for stability, and this one here, same thing, is gonna fold down for stability. I got some relief cuts right in here so that I'll be able to bend that piece in. These guys right there. And then we've got a couple little wings on the sides. So these will actually get welded to the outside section of our cart. And this bolt hole and this bolt hole should line up, and that's gonna give us that tilting effect. So this whole thing is gonna swing back and forth, and then once we get done, we'll probably weld a little stopper in there or put something in there to keep that bottle from tilting forward too far. We're gonna go ahead and send this over to Cam and then start cutting. We got all our pieces cut out. I think this pretty much concludes, other than the vertical section of the bottle rack, everything that we need. We have all of our parts and accessories. So what we're gonna do now is we're gonna clean this up. I'm gonna label which way the bends go so I don't get confused. We've got these side pieces that are gonna bolt on here. That's gonna allow us to tilt back and forth. Other than that, I think we're ready to go. We'll get this set up and then we'll start tacking it up the rest of the way out, welding it out and detailing it. All right guys, we got everything that we wanted to get done today. We got everything bent up, got all the parts made that we needed. It's kind of getting late, so we're gonna go ahead and give this episode a wrap. Stay tuned for part 3 of the Heffner Performance build. We're finally gonna finish everything up and then get it all cleaned up, sent down to Sarasota and deliver it. So make sure you guys like and subscribe to the video. Put any questions or comments or concerns down in the comments section. Make sure you follow us on Facebook and Instagram. And until next time, make every weld better than your last. Welcome back to this week's segment of Weld.com. So today's sample is submitted from WickedMoto YT on Instagram. So last week we did a Facebook sample. This week we're going to go ahead and pull from Instagram, and we'll kind of alternate between the two to help everybody out on the different platforms. So WickedMoto submitted his sample. It's gas tungsten arc welding, 1/8" plates, and he's doing a lath joint fillet weld. He's using 2% lanthanated tungsten, 1/16 diameter, 10 CFH, 115 amps, and 1/16 filler metal. So the first thing I notice is the puddle spacing, right? So it almost looks like you are using a technique very similar to what's used in aluminum that some people use, to where you're running your puddle and you're advancing and stopping, dabbing the filler metal, and advancing again, stopping, dabbing the filler metal, and continuing on that route. What I would recommend that you do is have a slow, steady push that's continuous with your speed from right to left or left to right, whichever direction you're going to be heading, and then consistently add your filler metal. Get into a little rhythm, get a beat in your head, you know, listen to music if you need to. It's all about timing. But your torch angle should be about 5 to 10 degrees in a push angle, and just kind of move down that seam, you know, nice and easy, slow and consistent until you kind of get the rhythm and get the speed down pat. The next thing I noticed is that the top edge in a lot of your samples is eroded away. So you want to try to maintain the top edge of that weld sample as you're going through. So on this one I have about a 32nd, you know, maybe a 64th just below the top edge of that. You want to make sure that the top edge is still visible when you get done. So this is telling me a couple things. Either your travel speed is too slow, or your heat is excessive, but you're running 115 amps, so I don't think that's the case. Most likely the culprit in this situation is your arc length. So if you move your arc length too far back, that's going to cause an increase in voltage, and what that's going to do is that's going to cause a much wider puddle that's going to erode the top edge of that plate away. What you want to do is make sure you're about a 1/16 of an inch off the puddle when you're going through there, and just kind of watch the leading edge, watch the toes of your weld, because the toes of your weld are the edges of your puddle. Watch the edges of your puddle, because the edges of your puddle are going to be the toes of your completed weld. So as long as the edges of your puddle aren't eroding that top edge away, you should be fine. Other than that, I mean, it looks like you're consistently getting better. So do us a favor, keep posting your work. You know, I want to see your progress along here. Hopefully we can help you out further once you get, you know, these little things dialed in. You use the same hashtag, helpmeweld.com on Instagram, and I'll try and keep up with you and just help you along your journey. So take care, guys.
Welcome back to Weld.com, the Canadian version, you hosers.
I'm trying to work here. I don't come to your work and throw rocks at you while you're mowing. Michael, this is a safe space.
Hey Jason, can we finish this up tonight, buddy? Please? Hey Jason.
Oh, what?
Hey. You alright?
Yeah, I'm good.
Fell asleep with a cookie in your hand.
No.